Hello and welcome to this video. In this episode, we discuss ways to handle CSV files with bad records on Spark. We are going to explore how setting a specific mode while reading data can help dealing with the bad records. As we can see from the documentation, there are three modes to experiment with: permissive, drop malformed, and fail fast. CSV format is widely used to store data. However, sometimes CSV files have formatting issues, such as unmatched quotations, extra commas, mismatch on the number of columns, and so on. This can bring issues when reading data, leading to data loss, as bad rows can cause a failure to read the entire file or cause data inconsistency even if the file gets through. For the purpose of this video, we've generated a test CSV file mimicking some marketing data as an example. There are 10 records in total, where 6 records are well formatted and 4 are having formatting issues. Let's dive in to explore ways to handle records using the three modes we've just seen in the Spark documentation. To begin, we'll first run the imports, create a Spark session, and define a path to our data. For the first example, we are going to read the test CSV file in permissive mode. Reading in such mode would require adding an additional column to the schema to filter broken records to it. Let's provide a schema where we define expected data structure, as having a defined schema is important for accurately parsing the CSV file. Let's have a look at our read function. Among other attributes like data path, delimiter, and header, the key here is to specify the mode and column name of corrupt record. It allows Spark to process the file with formatting issues, saving info about broken lines to the corrupt record column. Keep in mind that Spark might fill missing values with nulls or skip the broken line entirely, depending on the error encountered reading a particular row. Moving on, here is an example of how we can filter the records using corrupt records column as a flag. To extract good records, we filter only rows where the column is null, meaning that the data is most likely valid. Similarly, we can get bad records by filtering the rows where the flag is not null, isolating the bad records for review. Assuming we could be interested only in specific columns, let's select a few. The select function returned 10 records. 6 records look good, but 4 have nulls in new user column. But even judging by the count of the records alone, we've got the bad records included in the output, as our test file has 10 records in total. In order to separate good records, let's define a new data frame that will consist of valid records only. Here, we select the data to a new data frame using corrupt record column as a flag. Also, we drop the corrupt record column as we no longer need it. The show function returns 6 good records, which means there are no bad records in the data frame. Let's check further by running select function with specified columns to verify we get only good records returned. We can confirm that the data frame consists of only good records. If there is a need to review the bad records separately, we can define another data frame by selecting the rows where the corrupt record column is not null, and export the broken records for manual inspection, saving data frame to a file using write_csv method. Bad records are now saved to a file that can be used to investigate the errors in formatting, as well as possible ways to troubleshoot them. While permissive mode allows processing records with errors, sometimes we might need to implement a way of handling data that is more strict. Let's consider our next example, reading test file in drop malformed mode. In this mode, bad records can be dropped in place. Similar to the previous example, we define a schema for our data, but only this time we do not need to add any extra column. As you can see, Spark completely skipped rows that have formatting issues and returned only valid records. To confirm that, let's run the count function and see how many records we have. Great! Spark returned 6 records. As we know, our file has 6 good and 4 bad records. In permissive mode, when running select on specific columns, we had broken records included in the output returned. Let's see if that's the case here. Well, it's not the case here. We do not see broken records in the output running select. Let's move to explore our fail fast mode now. Data schema in this example doesn't need to have any extra columns. We only define the expected columns and the data types. Reading data in fail fast mode throws an exception as soon as a bad line is encountered. When data integrity is crucial and the exception must be raised to stop the execution immediately upon encountering a formatting issue, fail fast is the way to go. In this video, we explored 3 ways to process a CSV file with bad records. In permissive mode, we can identify bad records and have an opportunity to review or export them. In drop malformed, we could entirely exclude bad records early while reading the data. And in fail fast, the execution was stopped the moment a bad record was encountered. That will wrap up our today's episode. I hope you have enjoyed the content. Please like and subscribe. See you around, and happy coding!